What is PISA? PISA is the OECD program for international student assessment. PISA measures 15-year-olds' ability to use their reading, mathematics, and science knowledge and skills to meet real-life challenge.
How does PISA, the Programme for International Student Assessment, work? Although it's the brainchild of the Organisation for Economic Cooperation and Development, based in Paris, France, the assessment is designed by education experts from around the world. In fact, since the programme began in 2000, every one of the more than 80 economies that have participated in PISA have contributed some of their best minds to creating a test the whole world can take. The assessment tries to find out whether students can apply what they have learned in school to real-life situations. It covers science, reading, mathematics, and some more innovative subjects like collaborative problem-solving or financial literacy. Countries volunteer to participate in PISA. If a country is not equipped to take part in such a large-scale assessment, regions of that country may participate on their own. Once a country is approved by the PISA Governing Board, individual schools are chosen based on stringent criteria to represent all 15-year-old students in that country. Students who participate in PISA are randomly chosen from among all the 15-year-olds enrolled in grade 7 or higher in the selected schools. They take the test in the same language they use in their normal classes. Students aren't asked to recall dates and names they may have memorized. Instead, they are asked to interpret texts, solve mathematics problems, or explain a phenomenon scientifically using their knowledge and reasoning skills. Students aren't given individual reports on how they did on the PISA test, but their scores count towards a national mean score. Despite what you may hear every 3 years when PISA results are announced, PISA is not just about ranking countries. It's about showing whether school systems are becoming more or less effective in preparing their students for further study or for work.
Why does PISA matter? Why is PISA so highly regarded by the educational organizations of developed countries in the last 2 decades? This is the first type of tests for international K-12 students, with a unified standard by developed countries, that have diverse cultures and systems of governance. The PISA test results have been used by the educational organizations of participating countries, to benchmark each own educational system versus the rest of the world, to learn, exchange experience with each other, and to improve one's own educational system. A case example is Germany. In the first PISA test in 2000, Germany students did not do well. In particular, there was a big difference between poorer students and wealthier students. Upon further studies of the problems, the German educators took actions to improve their school system. The result, German students made progress, from below the OECD average in 2000, to high performance above average in 2015. This is the PISA score ranking of the top 35 countries in 2015. Vietnam's score is 1,507, the same as Australia's, ranked about 21. Per the intention of the OECD PISA organizers, the test enables various countries to compare and benchmark one's own education attainment to others. As an example of benchmarking, there have been a number of Vietnam K-12 educators who were familiar with the US and France systems, and they can compare the Vietnam curriculum with those. Alternatively, Vietnam can also benchmark itself with countries or regions of East Asia that share the same Sinitic linguistic and cultural characteristics, including the Confucian education values. These are regions of China, Japan, Taiwan, and South Korea. Singapore is also relevant, as it is a Southeast Asia city-state with mixed Indo-Sinitic cultural influence. These regions have a mean score of 1,585, which is also something Vietnam educators can use as a benchmark. This is one of the use of PISA test results, as intended by the organizer. The Vietnam results drew attention and questions. The reason is that the Vietnam PISA scores and ranking in 2012 and 15 were a surprise. Something is going on. Vietnam has among the lowest GDP per capita, How could 15-year-old students from Vietnam score higher than the students in many countries with 10-20 times higher GDP per capita? The red underlined, in vernacular terms, is simply, if you are that poor, how can you be that smart? The notion that if you are poor, you can't be too smart comes from this observation. There is a correlation between the PISA score of a country and its GNI or GDP per capita. Let GNI per capita be one axis, and the PISA score the other axis. The data of all the countries can be plotted on a scatter graph. Note that the GNI per capita axis is on the log scale. There is a trend that can be fitted with a straight line. It suggests that higher income is correlated with higher PISA score, and conversely lower income with lower score. The Vietnam data is an anomaly, because according to the trend, Vietnam students should have among the lowest scores. More precisely, it should have been 1179, 328 points lower. Extraordinary results warrant extraordinary scrutiny. Vietnam PISA test process was examined, and a problem was found known as the skewed population sampling problem. Ideally, 100% of students should be available to be randomly selected for the PISA test. However, it is difficult to have 100% available for most countries. In Vietnam, less than half were in the pool for selection. Based on demographic analysis, the unavailable half was less scholastically capable than the available half. If these had been included, Vietnam PISA scores would have been likely lower. How much lower? A rigorous statistical analysis by these authors was performed. One of their key findings is that even with the adjustment, the Vietnam PISA scores were still anomalously high. Specifically, the correction is approximately 14 to 15 points lower each test for the 2015 results. For the sum of all three tests, math, science, and reading, the adjustment is thus around 50. This figure does not make much an impact on the 328-point gap discussed above. The pesky problem of Vietnam PISA scores, namely, Vietnam is too poor to have scores that high, refuses to go away. This presentation is not concerned with this matter. Nevertheless, it is worthwhile to note that there are consequences with the Vietnam PISA anomaly. Vietnam scores are no longer officially accepted by the PISA organization. As mentioned at the preface, this presentation is fundamentally different from those cited work on the Vietnam PISA scores. In regard to scientific principle and scope, the difference between this work and other works can be put colloquially as follows: instead of speculating, if you are that poor, you can't be that smart, this work wonders, if you are that smart, why aren't you rich? A quick overview of OECD. OECD stands for, the Organization of Economic Cooperation and Development. OECD members are predominantly developed economies, including North America, Central and South America, Western Europe and Scandinavia, East Asia, and Australia. With regard to population, OECD constitutes 15% of the world population. In terms of economic output, OECD gross domestic product constitutes 38% of the world total GDP. A small percentage of population with an high percentage of economic output means that GDP per capita of OECD is larger, 3.4 times larger than that of the rest of the world. Given that knowledge is essential in the modern advanced economy, OECD PISA program helps bring awareness and cooperation in worldwide education, to help create an educated global workforce. In this work, PISA score and GNI per capita are combined together as a two-dimensional data entity. Their relationship is considered for correlation, but with a critical evaluation of the relationship validity. A quick side note, this work uses GNI instead of GDP like the others. The reason is outside the scope of this presentation, but the interested reader is referred to the World Bank article as shown. Similar to the above, but here, the PISA score is horizontal and GNI per capita is vertical. Replace flag icons with points for clarity. Step 1. Look at the histograms of individual variables. The PISA score distribution looks evenly spread out on the linear scale, but the GNI data distribution is highly asymmetric with a large dynamic range. Income usually obeys log normal distribution, hence, log scale should be used, and on the log scale, the GNI histogram are more evenly distributed. The data appears more evenly spread out. Step 2. Apply basic descriptive statistics. Shown is the covariance ellipsoid and its two principal axes expanding up to 2 standard of deviations. The ellipsoid is tilted and elongated, which are evidence that the two variables are correlated. Their relationship can be inferred with step 3, data smoothing averaging. A vertical and horizontal slice select the highlighted data points, and the nearest neighbor means are obtained. The red and blue mean points trace out curves that approximate the quantitative dependencies between the two variables. There is nothing fundamental to say that it is linear, however linear is the simplest approximation. Step 4, a simple linear regression line fit is obtained. The upward slope indicates that GNI per capita increases versus PISA score. The data appear scattered and not close to the line. How much confidence is there of this model? Step 5, test the model confidence. If GNI and PISA score are not correlated, the slope should be 0. The key parameter is the p-value, which is 6.3 times 10 powered to minus 14. It means that the chance for the slope to be 0 is only 1 out of 16 trillion. In other words, it is beyond any statistical doubt that the slope is not 0, that indeed, GNI per capita is certainly positively correlated with PISA score. Step 6, check the data fluctuation. The difference between an actual data point and its expected value on the model line is called residual or deviation. All data deviations can be obtained and plotted on the chart of deviations. Shown is the histogram of the deviations and the Gaussian model fit. The vertical dashed lines mark 2 and 3 standard of deviations. There are deviations that are so large, beyond 3 or more standards of deviation. Statistically, data points that are so far out from the distribution are called outliers. This is, for example, the largest outlier. On the scatter chart, the largest outlier is furthest out from the 2 sigma covariance matrix, almost 4 standard of deviations. It is the data of Vietnam. This is the origin of the Vietnam PISA controversy. There is a statistical model, a data point is too far off. What to do? Consider this argument. Its logic is as follow. 1. Vietnam GNI per capita must be correct, hence the Vietnam data point must be on this green line. 2. The model must be absolutely correct. 3. Therefore, Vietnam PISA score must be wrong as it should be on the model fit as shown. If the above discussion is too technical, the issue can be put in simple terms. 1. Vietnam is the poorest, or one of the few poorest countries participating in PISA. 2. If the linear model that says, the poorer you are, the lower your PISA scores should be were correct, then Vietnam should have ranked at the bottom. 3. Not only Vietnam scores are not at the bottom, they are anomalously higher than many much richer countries such as US, UK. 4. Hence, something is going on. A nice way to say that we don't believe you can be that smart, hence we don't count you in anymore. That's why Vietnam 2018 PISA results were not accepted. Is this a valid scientific analysis? This presentation is to look at Vietnam PISA scores with a rigorous scientific approach. Consider this analogy. A researcher conducted a study on animal weight versus the amount of food consumed by the animal. He had a high-tech setup that housed the animal separately and measured the weight of each animal. A food dispenser and control apparatus measures the food consumption. Then, he obtained data like this, food consumed versus animal weight, which looks good with a linear model. Looks good, except for one annoying outlier data point. Something must be wrong, he said. He conferred with the sales tech expert who sold him the animal weighing apparatus. Our company apparatus is perfect, it must be that the food consumption measurement was wrong. The food consumption should be here, not here. No way, said the engineer who set up of the food consumption apparatus. It must be the error of the weight measurement system. The animal weight must be here, not here. Who is right, who is wrong? It was an impasse. The researcher said, my equation is absolutely correct, looks at the straight line, look at the p-value, there is only one chance in 47 million that it is not correct. The sales tech said, our apparatus works fine, look at the self-calibration. The engineer said, my setup is perfect, look at the diagnostic results. As the three were discussing, in came the animal caretaker. She opened up the pens one by one, and said, oh sorry I didn't tell you. I found a little lost fawn in the backyard. I have nowhere to put it, so I borrow one of the pens. There is an alternative ending of this story. In this ending, as the three of them were discussing, in came a little 8-year-old. He asked what the adults were talking about. They explained to him the situation, and he said, oh no, the little doggy must be sick, he can't eat. The moral of this story is this, if you see a statistical outlier, chances are you are dealing with a different animal or a sick puppy. Where does this argument go wrong? Let's have an autopsy. Clause 1. Vietnam GDP or GNI must be correct, yes, most likely, check. Clause 3. Vietnam PISA score must be wrong, it should be on the model line, which is 1022. Vietnam PISA scores are likely off, but as these authors have analyzed rigorously, the total would be just 40 to 50 points lower, not almost 500 points, this is false. This leaves clause 2. Is the model correct, that is, applicable to the Vietnam case? A. Clause 3 must be true if clauses 1 and 2 are true. B. But it is false, hence, either clause 1, clause 2 or both must be false. C. Since clause 1 is true, then clause 2 must be false. Vietnam is a different animal. This scientific approach is actually quite common, it can be called hypothesis-driven. Let's look at another example of this philosophy. A person observed two objects falling, and declared his hypothesis and belief, a heavier object falls faster than a lighter object. Then he went to the Tower of Pisa to observe Galileo dropping two iron balls, one big and heavy, one small and light. Both fell at the same speed and hit the ground at the same time. Being his hypothesis driven, he declared Galileo must have done something wrong. Either the balls must have the same weight to fall at the same time. Or if one is heavier than the other, Galileo must have used a sleight of hand to throw the lighter ball faster initially than the other. This is the same type of hypothesis-driven argument that several authors have used to cast doubt on the Vietnam PISA scores. Something is going on with Vietnam and Pisa, like this person thought something was going on with Galileo at Pisa. The authors accepted the premise, if you are poor, you can't be too smart on PISA tests, as the truth, just like this person's conviction of his law of motion of a heavy object and a light object as a truth in natural philosophy. The habit of entrenchment in an existing belief even in the face of contradictory evidence is actually the prevalent mode of human behavior. In fact, human civilizations have been around for many thousand years, but only roughly 500 years ago that empiricism was finally formulated into a rigorous discipline, that gave rise to the scientific and technological civilization we enjoy today. The essence of scientific progresses is to recognize new knowledge in the face of empirical failure of old hypotheses. From Maxwell's classical theory and its failure to explain the black body radiation, the quantum theory was born. From one of the classic experiments that embodies the essence of empiricism, arose the notion that space and time are not absolute but relative, leading to special relativity. Both quantum theory and relativity replaced the old Newtonian mechanics based on empirical evidence, and so on. Modern science is driven by empiricism and rigorous critical thinking, not by beliefs, biases, or preferences. So, is the law of wealth versus PISA score as immutable as the law of nature? Science requires objectivity, empirical competency, and analytical critical thinking. Analytical and critical thinking concludes that this law cannot account for so many data points lying outside these 95% and 99.7% confidence bands, which means that there must be other factors determining the relationship between GNI and PISA score. Empirical competency requires examination of outliers like Vietnam, and this was well done, both identifying the undersampling problem as well as an estimate for correction. But objectivity? No. When you are an outlier poor in means and appearance, you are guilty when proven innocent. The issue is not with the Vietnam PISA score, but with its GNI per capita. Given the PISA scores, if Vietnam were similar to other economies that fit the linear model, then what could be inferred? Vietnam GNI should be on this line. The line is a linear model, the GNI per capita is on the log scale, hence the model fit formula is an exponential function. Based on this function, the expected GNI per capita for Vietnam should be almost $35,000 per person. The actual figure is 10 times lower. For the adjusted PISA score that is 50 points lower, the expected GNI is still 8.1 times higher than the actual. More generally, consider a normal distribution centering on Vietnam adjusted PISA score, with minus plus 2 sigmas spanning 100 points, as represented by the vertical slice. Then, the probability distribution of expected GNI per capita is shown. Vietnam GNI per capita is way off at the low end, but there are others also way off at the high end. It is clearer on the log scale, the Vietnam data point has an infinitesimal probability, less than 10 power to the minus 40, that is, 0. The curve expresses this model. An important feature of this model is the requirement of constant coefficient A. Example, if A is the rate of food consumption versus weight, constant A means that a healthy dog, a deer, and a sick dog all will eat dog food at the same rate. It is false. Vietnam probability is 0, it implies, per Bayesian inference, that the model is not applicable to the Vietnam data. There must be other factors involved, such as economic efficiency. Consider two identical workforces with the same level of skills and education in two different economic systems, one with high employment rate with high-paying jobs, the other with low employment and low-paying jobs, then naturally the high-efficiency economy would have higher GNI per capita. This is not idle speculation. In the US, the immigrants from less developed nations generally do much better than the counterparts in their own countries. Lastly, as an extra side note for the Vietnam science students, why is it wrong to single out Vietnam as an anomaly and cast doubt on its PISA scores? In empirical science, there are a few commandments like these. One cannot arbitrarily pick and choose some data and neglect inconvenient others. If Vietnam is an extreme outlier at one end, and the veracity of its data is questioned, which is a good thing, then one must also question the few outliers at the other extreme, such as Luxembourg and Qatar. If one believes in the model, that Vietnam is too poor to score that high, then one must also explain why Luxembourg and Qatar did not score at the expected value. So, for Vietnam science students, this table is a summary of the good, the bad, and the ugly in our case study of the Vietnam PISA controversy. Our animal researcher visits a farm and he is like a kid in a candy store. He also has so much dog and cat foods donated by the companies sponsoring his research. He is eager to do the study of animal weight versus food consumption again. But he can't put horses and chicken together and feed them with cat foods. He needs a system to sort the animals, which is called clustering. Clustering is a more basic step in data analysis that can be done even before considering things like model regression fitting. The Vietnam data was an outlier based on its deviation from the linear model. What if there is no model? Is the Vietnam data still an outlier? Consider this example. Even if someone has never seen a sheep before in one's life, the person can still spot the anomaly, or the outlier in this picture. We and many animals have a built-in quote-unquote clustering algorithm in our neurological processing repertoire. In this section, the Vietnam data point will be studied with the clustering and classification methods, analogously with the way we spot an outlier intuitively. As an illustration, consider the spectral clustering method. The data are separated into clusters, each of which has distinctive properties. This cluster, for example, appears to include high GNI economies with high PISA scores. This cluster also has high GNI but lower PISA scores, while this cluster is the opposite, high PISA score, but low GNI. A data point can be excluded from the data, and its distances from the clusters can be measured. The Vietnam data point is an outlier because it is the point that is furthest from all the clusters. Another perspective on the Vietnam data point is to compare clustering results without it and with it. It is so far out that its inclusion on the right affects many other clusters. Only 2 clusters with green check marks are the same, others marked with red crosses are highly dissimilar. This is an indication how far outlying a data point is. Outliers are also considered as single-point clusters. Clustering parameters can be set to agglomerate the data points into larger and larger clusters, and outliers are the leftover. All leftovers here are closer to its neighboring clusters than the Vietnam data point. This shows that without any model regression, the Vietnam data point is the furthest outlier. As such, its data should be verified on the matter of data accuracy principle, but not because of the belief that if you are poor, you can't be too smart per the regression model. Clustering method has no built-in context bias to identify the outliers. Left and right show various clustering results without and with the Vietnam outlier. It is evident that the Vietnam data point is either being single-point cluster, or the cause for the 2 set of clusters, left and right, to be quite dissimilar. As an example of the opposite, consider this test data point. Whether it is included or excluded, the cluster regions are the same for both left and right. This means this data is the antithesis of an outlier. As a final test, consider 2 clustering outcomes, DB scan and k-metoids. On the left, there are 3 clusters, and the right 2 clusters. The question is, for each case, which cluster does the Vietnam data belong? This can be done by using independent classifiers, different from the clustering methods. As expected, the results show some ambiguity of the Vietnam data point. For brevity and simplicity, only 2 classifying results are shown, neural network in the center, and support vector machine on the right. There are 2 main classes in each cluster result on the left, an upper tier GNI and PISA score, and a second tier. Neural network classifier is leaning toward the GNI criterion, and hence put Vietnam in the second tier, although close to the border between the 2. Support vector machine is more ambiguous. For the DB scan result in the top row, it charitably determines that Vietnam, perhaps, has the potential to be in the upper tier class. And for the k-metoids result, it places Vietnam data on the border, perhaps not too far off to determine that Vietnam is at a crossroad. The bottom line is, Vietnam isn't quite the case of a low GNI, as it is not entrenched in the middle of the second tier region. Because of its high PISA score, it is close enough and would be in the upper tier with some improvement of the GNI. Only the future can tell, which will be discussed in the next section. Focusing on Vietnam PISA scores is barking up the wrong tree. As mentioned previously, the issue is, if you are that smart, why aren't you rich? This section will examine Vietnam GNI per capita over the last 3 decades. Since GNI is an essential aspect in this presentation, it is worthwhile to take a quick review of it, and the follow analysis uses World Bank data as of 2022. Time series data of 218 economies are plotted on the left, and their statistical distribution is shown on the right. GNI per capita is expressed on the log scale, since it generally obeys the log normal distribution. More relevant to this presentation is the overall statistical behavior as shown on the right. As the time slice moves back and forth from 1962 to 2020, the exact distribution shape is not of interest. It is sufficient to consider its overall statistics, the mean mu, the median MED, and the standard of deviation sigma. With the log normal distribution model, it is sufficient to consider the mean, the median, and the spread of the standard of deviation. Without being lost in unimportant details, one can get an overall perspective of world GNI per capita the last 6 decades, specifically, the growth of the mean and median, as well as the variation of the distribution width, which is a measure of the wealth gap between poor and rich countries or economies. The wealth gap varies wider and narrower somewhat, but not dramatically. Meanwhile, and more importantly, the median and mean have increased by a factor of 20. That is the rate that the poorer and smaller economies have been able to catch up with larger and wealthier economies over the last 6 decades. From the 1980s to 2020, Vietnam GNI per capita has increased at an effective annual rate of 9%, more than twice the 4% effective annual rate of the world median. To benchmark the Vietnam figure on a relative scale, it is necessary to use the cumulative distribution plot. The plot shows the percentile rank versus log GNI per capita. Shown are the contours from 10% to 90%. The median, by definition, is the 50% contour, that is, the level where half of the world economies have higher GNI, and half have lower. Viewing Vietnam GNI data on the percentile plot offers a different perspective on the performance of Vietnam income and economy. For the episode from 1994 to 2008, it appears Vietnam GNI per capita increased with a healthy rate, a net gain of more than 5 times. However, this increase is modest relative to the world on the percentile scale, which is just about 10%, because the world was also doing well in comparison. From 2008 to 2020, Vietnam GNI increased slower than the previous episode, less than 3.5 times, but on the percentile scale, Vietnam actually gained 20%, because the world's growth was slower. Hence, Vietnam actually outperformed many other lower-tier economies in this episode. It is necessary in benchmarking that both the absolute and relative performance be considered. Overall, this chart shows that from 1995, Vietnam went from 0% at the bottom, to 40% in 2020. In the follow, the Vietnam data will be benchmarked by historical comparisons. Shown are GNI per capita of the world's 3 largest economies, the US, China, and Japan for the last 60 years. The Vietnam data can be time-shifted to be compared with the historical data of these countries. Japan data on the 70s, and China data of the 2000s represent among the highest, quote-unquote, economic miracle speeds in modern economy. Here the Vietnam data is compared to the precursor phase of the 1980s tiger economies, which also had the economic miracle speed back then. As a side note, Taiwan data is not available from the World Bank. The Vietnam data is compared to other Southeast Asia economies. Reconsider the original question, the Vietnam data outlying property. It appears that it is necessary to put the GNI in the time context. Whether Vietnam economy will continue its trajectory of growth or not remains to be seen. Vietnam participated in PISA 2018, but the results were not included as mentioned above. For the Vietnam educators, it is their burden and duty to ensure as large a population of Vietnam 15-year-old as possible to have a chance to be evaluated by PISA. It is not about ranking, it is a high valuable opportunity to benchmark the status of Vietnam youth education, and to improve by learning from the world. From the OECD PISA webpage as of December 2022, PISA already have the data for 2022, although it may take a while to be available, and PISA 2025 is in the work.